Hello students, welcome to the next lecture on the IIT JAM solution. Today I will explain you how you can solve the differential equation question with the help of the shortcut tricks. Myself Dr. Harish Garg. You can simply follow my YouTube channel where you can find the IIT JAM solution, and you can see the various PY question series is available in this lecture for your purpose. If you are interested to find the PY question, the differential equation, you can see the last 18-year questions available with the help of shortcut tricks. If you are new to my YouTube video, you can simply scan and join my WhatsApp group. So let's start with the first question. What is the first question is, this is related to the Bernoulli equation and C is my unknown. So I can choose, because for every C, I can choose any of the C. So let's say C is my 1. Fine. So then what is the Bernoulli equation is, I can simplify this equation as here. So what is the shortcut? How you can solve this Bernoulli equation? This is a simple straightforward formula for you. You can find firstly the integrating factor 1 minus n. If you compare them, n is my 3. Fine. P will be my minus 1. So can you find the integrating factor? E raised to power minus 2, 1 of dx. So integrating factor will be my e raised to power 2x. So I can substitute here y of minus 2, e raised to power 2x. N is my 3, minus of 2, e raised to power 2x. What is my q? You can see q is my minus 1. So it is a minus plus 1. Plus constant, because c is already written here, I called constant as a. So can you solve them? E raised to power 2x over y square. The integration of this is my here. Fine. Now can you see y of 0 is my 1. Can you find the value of a? Y of 0 is my 1. So that means 1 is 1 plus a. So a will be my 0. So finally your solution will be 2x over y square is e raised to power 2x. So what does the meaning of that? Y square is plus 1. Now take the limit as x approaches infinity. So it will be plus minus 1. But because this is the initial value, this is a first differential equation, the y naught is my positive, so it will converge to the positive 1. So this option cancel, this option cancel. B is my right answer of this problem. Look at this second one. Again you can see this is the first order differential equation. I can write this is minus y secant x is equal to 1. Can you find the integrating factor? E raised to power minus integration of the secant. Integration of the secant will be secant x plus tan x. So my integrating factor will be 1 over secant x plus tan x. Fine. Or I can say 1 cos x over 1 plus sin x. Now what will be the solution? Y into integrating factor, this, which is equal to integration of integrating factor into the right hand side. Right hand side in this case is my 1. So this will be log of 1 plus sin x. Fine. You can simply take sin x to be the by t, then it will be here. So then plus constant. Y of 0 is my 0. So 0, sin 0 is a 0, log 1 is 0. So a will be my 0. So finally my solution will be y cos x 1 plus sin x. Fine. This is my solution. Now you can substitute what is the value you needed. That is my 30 degree. What is the cos 30 degree? Root 3 over 2. 1 30 degree, that is a half cos 30 degree, that is my root 3 by 2. Sin 30 degree is my 1 by root 2. So it is a log of 1 plus 1 over 2. So it's a 3 by 2. So y over root 3 is my log of 3 by 2. So what is the right answer of this? Root 3 log 3 by 2. So these options are cancelled. Look at this another one. F is a family of the curve. Your target is to find the orthogonal trajectory. Fine. If you look about the option, h is not present. Can you find the value of the h easily from this? Y square minus 1 over xy is equal to 2h. Fine. Minus 2h. I called minus 2h is another constant here. What is the orthogonal trajectory means? You start from the dy by dx and finally you can replace to be minus dy over dx. So can you find the derivative of this? It is xy 2x plus 2y into y dash minus x square plus y square minus 1 into x y dash plus y over it is a 0. Fine. Now I can make the pair. First term is a constant term. So what is the constant terms are there? That means independent of y dash. So it is a 2x square y. Fine. It is minus x square y minus y cube plus minus plus y. So I can make the pair. This is x square y minus y cube plus y plus y dash. I can make the pair of the y dash. So what is the y dash is 2xy square minus x cube minus xy square minus plus x. So again I can make the pair. This is xy square minus x cube plus x is 0. Fine. Now I can replace this value to be x square y minus y cube plus y minus dx over dy xy square. Now there is no need to solve it completely. Look at the option. The first term is x square y minus y cube, but it's a plus. It's a plus. Xy square, all are satisfied, all are satisfied. Now you need a dy over dx. If you multiply that dy over dx, inside is a negative, but it's a positive. This option is also cancelled. A is my right answer of the problem. Okay, look at this another one. G is a continuous function and G is not given to you. The easiest one is you can choose G is my 1. Then your differential equation will be y is my 1. Fine. You can solve the problem. Otherwise, I can simply see from here. Okay, so what is the solution of this? C1 cos x plus C. Okay, but before that, I need to solve the C1 and C2. The best way is I can use the Laplace transformation. Fine. So what is the Laplace transformation of this? Is a s square Laplace of y minus s of y0 is a 0 minus 1 plus Laplace of y, it is 1 over s. So how you can find the Laplace of, it's a s square plus 1 Laplace of y, which is 1 over s plus 1. So what is the y? Y is my Laplace inverse of 1 over s square plus 1 plus Laplace inverse 1 over s square plus 1. This part is my sine of x because my independent variable is x, that's why it's x. How you can solve this Laplace? There are the two methods. Firstly, if you look about the options, then which term in the Laplace will look like say integration? That's a convolution. Fine. So what is the convolution of this? You have to find the Laplace of 1 by s. You have to find the Laplace of s square plus 1. So this is my 1. Fine. This will be my sine of x. So this integration will be 0 to x 1 into sine of x minus t into dt. So now 1 I can written as a g. So it is a cos. Cos, it will be the cancel out. Now you can see both are my positive, but the first part said negative. So this option is cancelled. First B is the right answer. There is one more way. If you don't remember what is the convolution result, what I can do is I can solve without the convolution part. So for that I can see how you can solve without the convolution. So this means 1 over s, that's the integration from g. It is my sine of x, but I have to integrate this with respect to t. So I can say this is my 0 to x and it will be my sine of x. So this is my dx. Okay, I can use the dummy variable. Fine, this is my dummy variable. So what is the integration of this? Is a minus cos t. So minus plus 1 plus sine of x. This is my solution. Fine. Now look at the option. If I start with the first part, this value is okay. So I will check the integration of this. The sine integration will be minus cos x minus t, and with respect to t is my minus 1 from 0 to x. So what is the integration of this? it is minus, when you substitute x, it is a 1 minus cos x. You can see that it's a minus 1 plus, but we need a minus cos plus 1. So first option is cancelled. You can see the second option is the correct answer of the problem. Okay, look at this another one. The differential equation is not exact, homogeneous, not homogeneous, and here. So if you compare m dx plus n dy, what will be your m? I can open this bracket, 8xy, 9y square. What is your n? 2x square minus 6xy. First of all, you can see the degree of the each term is my same. Fine, it has a degree 2, it has a degree 2, it's 2, it means it is my homogeneous. Fine, so it is not homogeneous, cancel out. Remember, if your m will be like here, x plus y minus 1, n will be like x minus y plus 7. So it has a degree 1, it has a degree 1, it has a degree 0. So all the terms has not the same, so it is not homogeneous. Anyhow, so the fourth option is cancelled. How you can check about the exactness? That means I have to check this value. So it is 8x minus 18y. Partial derivative of n with respect to x, it is 4x minus 6y. So clearly say both are not same. So that means it is not exact. So that means the second option is cancelled out. Not exact, not exact. Fine. Then whether the x square is an integrating factor or not. What is the meaning of the integrating factor? If I found the new m after multiplying the x square, it is here 9x square y square, and n dash is 2x raised to power 4, 6x raised to power cube. Now again I can found this and this. If both are same, then yes, x square is the integrating factor. If both are not equal, then it is not the integrating factor. So if I found this, it is a 8x cube minus 18x square y. What is that? 8x cube minus 18x square y. Both are same. So it means yes, x square is my integrating factor. So x square is my integrating factor. This option is cancelled. Okay, look at this one. Again, it's a linear equation. So integrating factor will be my e raised to power 2 dx. That means e raised to power 2x. Solution will be e raised to power 2x, which is integration of 2x divided by 1 plus x square into dx. Fine. Y of 0 is alpha. So if I substitute y of 0, okay, but this, okay, I can integrate from 0 to x. Fine. Plus, so now clearly say y of 0, that means when you substitute x is 0, is a 0 to 0 is a 0, and e of 0 is 0, so it will be my alpha. Fine. Now your target is to find the limit as x approaches infinity. So what is that? It is x to 0 e raised to power, okay, fine, because I can I can say this is my 1 plus x square, or you can use as a dummy variable. Fine, you can use as a dummy variable because the limits are my same. So this is my e raised to power t, 1 raised to power this, plus alpha over e raised to power 2x over e raised to power 2x. Now take the limit as x approaches infinity. This value will be my 0, whatever the value of the alpha, because alpha is my constant number. So that means limit x approaches infinity, x to 0 is a dummy variable. Fine. So divided by e raised to power 2x. So it's a, you can see denominator is my 0. What about the numerator? How you can say about the numerator? So you clearly say this numerator, because e raised to power 2t divided by 1 plus x square, this is my continuous function. So that means it is my integrable function. Fine. Moreover, we all know e raised to power 2t is always be greater than of the e raised to power 1 plus this. So the ratio of this will always be greater than 1. So that means when you take integration of 1, so that will, when you take x is infinity, it will be my infinity. So when it's a infinity, denominator is also infinity, so it's a infinity by infinity rule. So I can apply the L'Hopital rule. So what is the L'Hopital rule is? This is e raised to power 2x over 1 plus x square divided by 2 times e raised to power 2x. So it will be cancelled out. Now you can substitute the infinity, it will be 0. So the limit of x approaches is 0 for all alpha. So that means it is for all alpha is the right answer. Fine. There is one more way you can think about that. Fine. How you can think about that? You can see. We all know 1 plus x square is always be less than or equal to 1. So my differential equation will be less than or equal to 1. Fine. So that means I can see the solution of this will be less than or equal to, this solution will be c e raised to power minus of 2x, and corresponding to the 1 will be my here, that is yc plus yp. Fine. Now if I choose y of 0 is alpha, what is my alpha? So y of 0 is, this is alpha, this is c plus here, so c will be my greater than or equal to alpha minus half. Fine. Now I can simply take as the equality component. So what will happen if I simply take the equality component? So y, or there is no need of them, I can simply substitute the limit as x approaches infinity. So this number will be c over e raised to power minus 2x plus half. This part will be 0. So the limit will be less than half. So he said 1. Fine. Does not exist. Cancel out. Fine. But you can't say whether it's a 0 or not. For that I have to use the previous concept. Okay, look at this another one. Let y is the solution of this. Can you find the solution? M square minus 2m plus 1. So that means solution will be c1 e raised to power x, c2 e raised to power x into e raised to power x. Fine. Then for this I can find the yp, which is 1 over d square minus 2d plus 1. So it's a twice. So x square over 2 into 2. So that means x square e raised to power x is the right answer. Now what is the statement suggested you? You have to say f is my greater than 0. When it will be greater than 0? When I can simply choose c1 and c2 both are my 0. Fine. Then your y will be x square e raised to power x, which is always greater than 0 for all x in the R. Now we can see whether the y dash is greater than 0. What is the y dash? It is my x square plus 2x. Does it greater than 0 for all x? No. Clearly say when you take x is my minus 1. So in that case y is my greater than 0. But what is my y dash? E raised to power minus 1. 1 minus 2 is a minus 1 over e, which is less than 0. So that means the first option is cancel out. So P is correct. Both are correct. These two options are cancelled. Fine. Now second is when the derivative should be greater than 0. Fine. So it means firstly we need to find the derivative. So what is the y dash? c1 e raised to power x, c2 x e raised to power x plus c2 e raised to power x plus x square e raised to power x plus 2x e raised to power x. Fine. Now what is the c1 and c2? Again it is not given to us, so you can choose any number. You can see I can choose x is my 0. What is my y dash? c1, this is 0, plus c2, this is 0, this is 0. Fine. So when x is 0, what is my y? c1, only c1. So if I assume this number is my greater than 0, can you say this number is always 0? No, because I can choose c1 is my minus 1, c2 will be my 3. So clearly say this number is greater than 0, but this number is less than 0. So but he said for all, I can simply choose x is 0. This condition is not satisfied. So both are my false statements, the correct answer. Okay, look at this one. This is very simple. I can simply solve this equation. So it will be 0. M will be minus of 2 plus minus 16 minus 20 over 2. So minus 1 is a plus minus iota. So your solution will be e raised to power minus x c1 cos x plus c2 sin x plus what is the yp? So it is 1. So 1 means 1 over 5. Whenever it's a constant, you have to take the coefficient of the y. So now your target is to find the x approaches infinity. So when you take x approaches infinity, this will be 0. So that is complete 0. Answer is 1 over 5 is the right answer of this problem. Okay, look at this another one. Again, you can solve this. This is 2m square minus m minus 1. So I can factorize them. 2m plus 1. So 2m minus 1. Or you can see it's a minus of 2m plus m minus 1. So that means 2m plus 1 and m minus 1, 0. So my solution will be c1 e raised to power x, c2 e raised to power minus x over 2. Y of 0 is 1. c1 plus c2 is my 1. Y dash 0. So c1 minus c2 by 2 is my alpha. The smallest value of the alpha for which y has no critical point. So what is the meaning of the critical point? Y dash is 0. If I substitute here, y dash is c minus c2 over 2 of minus x by 2 is 0. So I can see this is e raised to power 3x by 2 is half c2 over c1. Now we need a no critical point. When it will be the no critical point? Only when c2 will be 0. Fine. Now you can see about that. For what value of the alpha will be here? So can you solve them? If you subtract them, it is 3 by 2. It is 1 minus alpha. So c2 will be 1 minus alpha of 2 by 3. Now clearly say when it has a no critical point, when you are unable to find the solution of this problem. So clearly say e raised to power this. If I prove that it will be the 0, it means you are unable to find the x. So when it will be 0? When c2 will be 0. So when c2 will be 0? When alpha will be 1. So that means answer is alpha is equal to 1 is the only answer when it has the no critical point. Okay, look at this another one. Consider the alpha which is 3.14 into 2. So 6.28 comma 0. It is my 0. It is my 6.28 minus 5, 4 and then so on. For which all the corresponding real solutions is approaches 0 as y approaches infinity. That means whenever limit x approaches 0 positive, this part will goes to the 0. Then the intersection of this. So z is my positive integer or negative integer. D is my here. So what is the set? Minus 6, minus 5. These are the values. Fine. This is my intersection. Now, what is that? It's a Cauchy-Euler equation. I can write this equation is m square plus alpha minus 1 into m plus 1 is 0. Always remember, whenever you have the Cauchy-Euler equation like P a x y dash plus q y is 0, you can write the equation directly as a m square plus p minus a into m plus q is equal to 0. In this case, a is my 1, p is my alpha, I can written here. So what is my root? It's a minus b, I can written here, plus minus b square minus 4 over 2. Fine. Now you can see I can return this number as here, plus minus 1 over 2. I can factorize them, a square minus b square. So a minus b and a plus b. Fine. Now that's over. Now you can see I can check about, because whatever the coefficient of this, my solution will be c1 If it is a complex number, then my solution will be of this C1 cos of this plus of this. Okay. If it is a real number, then we have the solution of this e raised to power this end. So I need to check firstly what is my range of, fine. So 0 is less than, minus alpha is less than of this. I can add 1 minus alpha, that's a 1, this of here. So that means this number is always positive. Fine. This number is always positive for each alpha. So what is the meaning of that? Whatever is there, it will be my here, it will goes to the 0. Why? You can see, because this is a Cauchy-Euler equation. So my solution will be 1 minus of this. If this is a complex number, then it will be cos of this plus sine of this. Otherwise, if this is a real number, then my solution will be this plus of minus with the positive sign with the negative sign. So in both the cases, if this is my complex number, then because this value will be 0, so hold the term 0 for each alpha. Now what will happen? We will see what is the range of this. Now clearly say what is the 1 minus alpha. What is the maximum alpha is minus 6. So this number will be my 7. 1 minus alpha will be 7. What is the maximum value of this? Minus 9, minus 4, minus 6, minus 5, 45. So what is the root of 45? It is 6 point something. So definitely this number, that means this number is always be greater than of this number. Fine. So it means if you plus minus them, what is that? This number is always positive. Whether the positive sign or the negative sign, it means my solution of this is always positive, and it means it will goes to the 0 when you take x approaches infinity. What does it mean? For what value of the alpha? This range. That means all the values of the alpha. So how many intersection points are there? You have the 6 intersection point. So the right answer is 6 is the correct answer. This is a very interesting question here. How you can see, I can again explain you. You can see about that. My solution will be 1 minus alpha over 2 plus minus alpha minus 3 alpha plus 1 of this. So let's say firstly case 1, assume this number is my negative. That means where it lies, when it will be the negative, when it lies between minus 3 to plus 1, but we are bothering only about here. So whenever alpha lies between here, this number will be my negative. So that means it's a complex number, but 1 minus alpha by 2 is always a positive number. Then the solution will be x minus of this C1 cos and C2 sine. So as x approaches infinity, this will goes to the 0. So that means whenever x is minus 1, x is my plus 1, minus 1, minus 2, minus 3, the answer will goes to the 0. Now what about the other parts? When it will be the positive? When it will be the positive, when the value of the x is lies between here. Fine. In this case, this number is my positive. When this number is my positive, it means this solution will be my all real numbers. And we have seen 1 minus alpha is always be greater than of this quantity. You can take any of the alpha in between them. It is always a positive. So that means whether you consider as a positive sign or you can consider the negative sign, this whole number is my 2 positive roots. Both are my positive. So my solution will be x of m1 plus x of m2. So now once this number is my positive, when you take x is 0, this all are goes to the 0. So in this case, minus 6, minus 5, minus 4 also goes to the 0. This is also goes to the 0. So how many values of the alpha for which this number goes to the 0? For all those pairs. So how many intersections are there with the positive integers or negative integer? That's a 6. So 6 is my right answer of this problem. It's a very interesting question. There is a little bit concept about that, but it's all about the simple questions for you. You can simply scan and join my WhatsApp group if you want to find more discussion on such one. I hope you can like and share my comments on videos. We will see the next lecture on some more lectures on the IIT JAM solution. Till then, best of luck students. Happy learning.